Hi everyone, welcome back to PSTAT 5A, week 7. We're going to continue our inference on population proportions with a hypothesis test. Now, the data I'm using will be continuing from example 7.1 that you can find linked earlier. So what we have again is data on Santa Barbara residents. 100 out of 186 Santa Barbara residents have a Netflix subscription. And we want to test this against a claim that says a majority of SB residents have a Netflix subscription. And our test level will be at 10%. So what we're going to look at now is this claim. And so looking at the parameter of interest, we're looking at yes-no situations. So we're looking at proportion of residents who have a Netflix subscription. So that is this symbol P. Now, if the claim is that a majority of the residents, then that means more than half. So again, I like to start with just translating the words into symbols, and that's why this will help me identify what's going to be my null alternative. So remember, the rule is that your null hypothesis must have an equality statement and your alternative an inequality statement. And so I'm just going to look at the claim to see which one it is. And since this is a strict inequality, that's going to go in the alternative. And I'm going to identify that this one is my claim. And therefore, my null is the counter to that. So it's the complete opposite statement. So that's the first part of our setup, it's just identifying where the claim is going to be located. Now, just like in unit 6, our p-value is going to be the probability that the data is at least extreme as we've found. So for this problem here, the p-value, and again, the p-value is that evidence. So when the p-value is small, you're likely to reject the null. When it's larger, then you're not going to reject the null. So in this case here, our p-value is the probability that our data, and again, our data is p hat, the sample proportion, is going to be more than what we observed, which is the 100 over 186. And then from unit 5, so recall that p hat is normal in certain conditions. And again, those conditions are, we've got a binomial, we've got n times p is at least 10, and we've got n times 1 minus p is also at least 10. I won't check it here, but you can look at the values. The binomial part is every resident either has a subscription or not. The n is our sample size, and in this case, p is unknown. However, under hypothesis testing, we always assume the null to be true. So the value you would use there would be the 0.5. Basically, what this means is it means I'm going to standardize my p hat to a z-score. And that z-score equation again is right here. And so when we plug everything in, our p hat is our data value. And similarly, the value for p, again, under the null hypothesis, is assumed to be 0.5. And now I'm just going to use my z-score equation here to find out what's the z equivalent. And this will allow me to locate the probability on my z table. So if I run through all this calculation here, I get a z value of 1.03. So to summarize, the p-value is the probability that my data is at least 100 out of 86, but because p-hat is normally distributed, I can standardize that to a z-score. And then the nature of my z-table is it gives me areas to the left. So I'm going to rewrite it this way using my complement rule. And then now I can just go and find this guy on the z-table. And give me a minute here, a second, I will look this up. It appears to be 8485. So finishing this up, I get a p-value that is 0.1515. And again, that's the value I'm using to test against my significance level or the test level. And what we said earlier was that larger p-values are evidence in favor of the null, and smaller p-values are evidence against it. And so how big or how small depends on that significance level. So for this problem here, since this p-value is larger than 10%, right, it's larger than alpha, which is our 10% here, then that's going to tell us to fail to reject the null. And so ultimately, that will be our decision. So what that means is if we go back and look at the beginning, we have a claim that suggests that a majority of residents have a Netflix subscription versus a counter to that claim that says the opposite. And the idea is to look at our data and see which side our data supports. And since the decision says that we're not rejecting the null, we fail to reject the null, then between these two, this is the one that we don't have enough evidence to go against. So ultimately, while 100 over 186 is larger than 0.5, we're saying it's not large enough for us to throw our full support behind the alternative hypothesis. That is running through hypothesis test for population proportion.